Ewa Gasperowicz, and I'm an engineer on the Chrome team at Google. And today I wanted to talk about caching API and service worker, and those are two core technologies for progressive web apps. So my first question to you is, have you heard about progressive web apps before? Yeah, have you heard about service workers or used service workers? Oh, perfect. That's like 50-50 split. So we know where we're standing. I believe that when they're done right, the caching and the service worker implementation on your site, they can give you a tremendous advantage in terms of your site's performance, not only in terms of the offline capabilities. So my plan for this talk is to share with you how I approach designing service worker for my projects, for my sites, especially which part of service worker I take into consideration, and I advise you also to be careful about. If you have any questions, feel free to, we're a small group, so you can just, interrupt me and have a question straight away, or we can also discuss it after the session. Okay, shall we start? All right, so we start at the very beginning, right? Before the progressive web apps became a thing, the world was really simple, Actually, our options were very limited. In terms of connectivity, there were only two states. Either the user was online or was offline, right? And that was it. Almost. Well, actually there's also a third state, which we tend to call Li-Fi. Do you know what is Li-Fi? Li-Fi happens when the device of the user thinks they're online, so you can see you have connection, kind of, but the internet is not really working because either it's too slow, or there's some DNS problem, or there is some connectivity issue. And this Li-Fi is actually more dangerous than being entirely offline, because it's like a Schrödinger cat of connectivity, the user is online and offline at the same time. So everything in those times before progressive web apps were a thing relied on the network. If your user was connected and they had connectivity, they could get back a website from their request, right? If there was no connectivity, they could get a dinosaur or whatever their browser decide to display when there is no connection. And when there was Li-Fi, usually what they got is a mess. What I mean by a mess? Here's an example of a page that I made sometime. Can you actually see, or do I stand in front of it? You can see the screen? Okay. So this is an example of an e-commerce site I built recently. And when you're online, it's a nice, rich experience, right? But when you're on Li-Fi, it might happen that some of the resources, like for example, base HTML is downloaded, but other resources fail to load. For example, the images don't display. I often see those pages where you kind of get a page, but it's kind of broken at the same time because not everything is displayed. That's not very pleasant for the user. It can be even worse. For example, if the styles don't load properly, then the site is really unusable. It's not only unpleasant, it's really unusable. And the biggest problem with Li-Fi is that when the user was offline and they could get a dinosaur, they know they have a network connection problem. So they blame the network. But if they get this experience, they don't blame the network or the device. They blame you, the owner of the site. So, the site is broken. Those developers don't know what they're doing. They're wasting my time, right? Which means this type of experience on Li-Fi leads to users' exits. And once they exit your page, they might never come back. So it's dangerous for businesses, it's dangerous for companies, and for people also passionate about their projects. Fortunately, service worker and caching APIs are here to help us, right? To make our sites more reliable in this type of circumstances. So my colleague Jake made this website, is service worker ready, some time ago, and it contained a lot of information about the state of implementation. And recently he swapped it to the simpler version. We just said yes, and he was very happy about it. This means that service worker right now is supported in all modern browsers. And for us as developers, the consequence is that we can move from using it only as a progressive enhancement to actually treat it as a core part of our site's architecture and be really serious about it. So, what really is a service worker? Some of you worked with it already. It's just a script that you can write yourself in JavaScript that serves as a proxy. It sits, you can install it on your page, and then it sits between your page and all kind of network connectivity. So it can intercept your requests and decide what to do with them. So for example, if there is a Wi-Fi or there's any connectivity problem, instead of getting the resources back from the network, it can fall back to some other source, for example, storage. In order to make it work, you can either write it all yourself, or you can leverage help of some of the libraries that are out there that help you with implementing Service Worker. In this presentation, I'm using Workbox library, which is written by some folks from Google, and it's also open source, so we get external contributors as well, which make implementation of Service Worker much easier. But the general strategies and general concepts I'm talking about are not only relevant to Workbox users. They're like general principles of designing Service Worker, also if you write it from scratch. So if, caching stuff in our cache and then serving it from the cache via Service Worker is so good and can provide us some leverage in terms of performance, maybe we should, just cache everything. Put everything in user's cache and serve from there and don't rely on network anymore. While it's really tempting, because it's really easy to do. For example, with Workbox, you just need 8 lines of code or so, depending on formatting, to cache all your site. It's very easy to do these days. I do not recommend to do that. And why is that? Because progressive web apps, one of their main advantage is that they serve the long tail of the internet. They often serve the users that don't want to, use your app every single day, because otherwise they would probably install a native app for the ease of use. And this means that the size of the app really matters here. Imagine how many apps you use on your phone and how many websites you visit on your phone. If every website downloaded all the resources it's going to ever, perhaps, maybe use at some point, that would mean a lot of storage. So just dumping everything to the cache should not be your, first choice of strategy. You need to be more granular about it. Also, web is different from native in a way that we operate on URLs rather than entire sites, right? If you don't have a single page application, which is a case for a lot of e-commerce sites and so on, you actually have multiple URLs on your page. And even in a single page application, you have multiple views, which means the size of your app is not just the size of your homepage, right? It's the size, the collective size of all the URLs that the user might visit throughout their entire, session or multiple sessions on your site. So it's not enough to just check the network tab and see okay, I opened this URL and it apparently took 500 megs or resources, and that's the weight of my app. That's not true, because if you go to next URLs, it might require more downloads. So how to actually check how much a site, not a single URL, but how much a site weighs on user device? Well, this is this website I showed you before, and let's say I opened the the Chrome DevTools panel, right? And in the panel code application, you need to go to this clear storage place. And this is a very scary moment, because I'm very scared of pushing a button that says clear everything. But you should not be afraid, because it doesn't clear anything. I know that's not ideal choice of naming, but that's where you go. And then you see all the details about how much storage your app uses. These are all URLs that belong to a given origin, and only then at the very bottom there is this dangerous button that clears everything. So that's how you check the size of your site, as opposed to the size of a single URL. And now let's look how the size looks throughout some kind of life cycle of how your user is using the site. Let's say the user visits this page, it just loaded, so the storage is pretty low. It's pretty much just initializing some stuff. Once the Service Worker is installed, it takes about 30 kilobytes. And then it starts to cache resources that it's going to use for this user. If all of the homepage is cached in case of this website, it takes around 150 kilobytes. That's very acceptable for a website, right? But then when the user navigates to to different categories on my site, I keep adding them to the cache. So at the end, I end up with 1.4 megabytes of the size. This means that it's a little bit tricky to measure the size of your app because it changes throughout the life cycle of your app, which means it's not so easy to say like, oh, if you install this app, it takes like 200K of space and that's it, right? It might differ depending on the caching strategy you're using. So the lesson we learned from it is just be mindful of the resources you're using and get into the habit in your development workflow of checking how much resources, bandwidth, and storage you're using on your user's device. We have this saying in my team that hope is not a strategy. You need something better. So my first tip to you is you need to have a plan. And generally in software development, by plan we mean a design, right? So this whole talk is about how to actually design a proper service worker so that it doesn't store too much stuff and still is good for the performance of your site. So that's the designing of the service worker. As I told you before, service worker is a proxy, so it sits between your website and all the kind of external world resources, network resources. So in natural way, it divides this flow into two parts. The way how service worker communicates with the website, I call the serving part of the strategy of designing service worker. And the way how service worker actually gets the resources from outside is the caching part. So let's start with caching, right? How to get stuff into the cache. Well, there are a few important questions you need to ask yourself when deciding how to design your cache. The important questions are what to cache, when to cache it, how to efficiently update, and the most important question, which is what not to cache. That's super important stuff because we often end up caching stuff that is unneeded and it's just wasteful, it wastes bandwidth, it wastes storage. So what not to cache? Well, don't cache trash. And by trash, I mean resources that should not be there in the first place. And I wanted to say we're all guilty of it, but maybe let's not generalize. I'm often guilty of putting trash on my websites because I'm not ideal and my projects are not ideal. For example, I have like unoptimized images on my site, or it might happen that I have content that is not gzipped or that is not properly formatted, or I have some library that I don't use but I kind of forgot to remove it from my build and it's still being shipped, right? So all this stuff should be, if you even consider adding any caching to your site, you should optimize this performance, like fix those performance issues beforehand, and that would make your caching much easier down the road. Now, yeah, so those are all the resources you should really remove. And if you would like to learn in a more structured way how to remove all those parts that don't belong to the website, you can follow this link bit.ly/PWA audit, and we have some guides there that can help you with this cleanup. So once we cleaned up all the stuff that we don't know it's not necessary, everything else is kind of necessary, but not everything is equal, like different content have different importance or function or weight on our website. Let me show what I mean by this. This is a website for Women Tech Maker movement, and I worked on it last year. We were preparing it to become an offline site because it's often used in emerging markets, so then it's much easier to use when the network is slow or non-existent, right? So it's very visual site, it's very rich, there's a lot of graphics on it. I tried to cache it all just to see what happens, and it blew through my quota pretty much. So that was not the way to go. I needed to decide, okay, I need to prioritize like what to cache and what not. So I looked especially at the graphics, at the images. I said, what will happen if there are no images on the site? Well, it's not only ugly, but it's actually unusable. Like the user can't navigate anymore. So no images is not an option. All images is not an option. What should I do? So I started to look at the images in a more functional way. The ones that are highlighted in yellow in here, I call navigation and action images. Those are super important images because they actually allow user to use the site, right? Which means they need to be there. If they're not there, the site is unusable. Simple as that. Now, the red ones I call branding and priority. This means that if they're not there, the user might not cry, but my business will cry. You know, it's something that creates the connection between the user and my brand, or has some priority for some reason important to my business. So I really put a lot of effort in making sure those images are done right. Now the blue ones are the ones that are responsible for the look and feel, which means it's nice when they're there, they add to the experience, but if they're not there, well, it's not the end of the world, okay? And green ones are kind of interesting because they're informative. In this case, there are logos of the website, so they don't only look nice, they actually convey some information similar to textual information, right? And this means that I can treat these different groups of images in a different way. So here you see how the site looks on low connectivity, right? The yellow ones, they're super important, so I just inline them, and they're small, they're SVGs. I can put them in my HTML directly and never ever worry about caching them, because if the HTML is there, they're going to be there as well. The red ones have a priority, so I pre-cache them. I always fetch them ahead of time, put them in the cache, and serve always from cache, because then I know, okay, they're going to be there even if the network is down. Then the blue ones, I cache at best effort, which means like I cache the first 50 of them or so on the first come, first served basis. And if they're not there, like the banner one is not there and this one is not there, it's not the end of the world. Like the user can still work with it. And then the green ones are, they were the informative images. I provide a fallback image, but with an alt tag. So in alt tag of the image, I wanted to convey this message, the name of the company. So here I use the scripting capabilities of Service Worker to prepare, you know, a fallback for those images to still have this information available. So the tip number 3 is that you need to be selective. You need to understand different resources on your site and what function they bring, so that you know how to cache them afterwards. And we'll go back later on to this example and I'll show you how to solve it actually in code. Now, when to cache. When it comes to when, we need to understand the life cycle of Service Worker. So first, when the Service Worker is fresh and new, it gets installed, and then it gets activated, which means it starts to control all the tabs where your site is opened. And then it runs, which means it responds to requests from the page. Usually these are fetch requests or direct messages between the page and the Service Worker. So in these two places, in the install event and during the runtime of the application, that's usually where we cache resources, and they differ a little bit. So in the first case, we call it pre-caching, like caching ahead of time during install. And then when you do it once it's already running, we call it runtime caching. So now what's the difference? Pre-caching pushes assets to the cache ahead of time. It's very good for static assets like style sheets or images or scripts because they can be versioned, right? Like you often version different resources, adding hash to URL so that you can upgrade the version when the new content is there. And this is not so easily doable with navigation URLs, like, for example, homepage and so on, right? You don't want to add a hash to the URL. And versioning is important so that you can update your resources efficiently. Those resources are usually, they're installed during the install event, so they usually get updated only when the new Service Worker is installed. So here, if you look into this example, this is an example of pre-caching. Here you can see that all the resources have like hash attached, so that the Service Worker knows, okay, if this number changes, it means I need to download new version, and the version of the Service Worker changes as well, because like pretty much it means the new Service Worker is being installed. So really you need to use content-based versioning for efficient caching. And what I mean by content-based versioning, well, this number in the URL can depend on arbitrary things. For example, it can be a timestamp when the build was made, right? Or arbitrary version, like version 15 of my site. If you base it on such arbitrary data rather than the actual content of the page, you'll end up with wasteful caching. Because let's say you have 15 scripts on your site, only one changes, you prepare a new build, and all 15 files get a new hash. That's not good. It's much better if the hash is based on the actual content of the page, so that 14 URLs for the resources stay the same, and only one is changed, the one where the actual content changed, and only one is being re-downloaded. Yeah? You save the bandwidth, and you save some cycles on the user's device to do that. Oh, sorry about that, the green dot. I hope it's still readable. So precaching is very easy because you can, during the install event, just compare what you have in the cache, what other resources are needed, and replace the ones that need to be replaced. So it's very easy to manage because there is a given moment in life cycle where you do that. It's good for performance because you're precaching stuff before user needs them, which means once the user requests given images or scripts or something, they're already in the cache. So it's good for the performance, and also it's usually known size. This means that, for example, during your build step, you can just wait all of the resources that you want to precache, and then okay, this will take 1 megabyte of space on user's device, and you can be happy with that. Now the cons are that it's arbitrary. You need to decide yourself which ones to cache in this way first. You can't rely on, for example, user accessing the content first. It can also cause an upfront network cost, which means while this install step is running and those resources that are going to be needed in future are being downloaded, other requests from the page can slow down because there's network congestion. So you should not precache too much stuff, or wait with the precache, for example, till after the DOM content loaded fires, so that okay, these requests are not competing with the requests that are needed right now. Like the future requests don't compete with the current requests that you have on the page. And it's hard to update unversioned assets, like I mentioned with the navigational requests, for example, the homepage, because you don't want to have some arbitrary, hash number attached to the URL. Now, runtime caching is caching that happens during the life cycle of the application once the service worker is already running. So it's very good for the dynamic content. For example, when you have the same URL, the content changes, but the URL stays the same. For example, like for a blog post, right? For SEO purposes, you don't want to change the URL because you updated your blog post a little bit. So it works also for non-revisioned assets because of this. It updates depending on the strategy, so you don't need to replace the whole service worker to update your content. So you can refresh it kind of much more often than by reinstalling the service worker each time. And it's good for non-crucial content, which means it's slightly less optimal for performance because those resources need to be requested first before they end up in the cache. So they give you like advantage of serving from the cache only on kind of second try. The first try always comes from the network. Here's an example. Usually what happens in service worker, you just add a listener for the fetch event. So when the fetch event happens on your website, the service worker intercepts it in here, and then you go and fetch the actual resource from the network, and then you both return the network response to the page, but also put something in the cache, right? So only when the fetch event happens, some stuff ends up in the cache. And that also brings us to some of the negative consequences of the runtime caching, which means some assets will install or update only when the user accesses them. Which means if you're not careful, you might end up with resources that are out of sync. For example, if you have resources that depend on each other, some of them are being cached in the install event, and some of them are being cached at runtime. They will update at different moments in time, and there might be a moment where their versions are not compatible. So you need to be careful and plan accordingly for that. The biggest difficulty though, is that the cache grows over time, as I showed you before, right? Here, if I cache my home page entirely, it's around 150, but if I add accessories page, it's around 300 kilobytes. If I add apparel page, it's around 900 kilobytes. And this is a very small page, so it goes to 1.4 megs for all the pages. But if the site is really big, like Amazon.com, you can only guess, how much space it will take. So you need to have a proper way of cleaning the cache and staying below the quota to manage this scenario. So you always need to have a way to control the size of the cache and beware of running out of quota for big sites if you use runtime caching strategy, because you can't just wait everything at the beginning and see if it fits below the quota. Now, the serving part of the strategy, which means how service worker returns the content to the website. So usually there are three places where the service worker can get content from. It's either network, either cache, or it's some combination of these two, or some generally scripted logic. This is just a piece of JavaScript, so it can use, for example, the same templating logic as you're using on your server. Your role is to combine these three resources in a way that is most performant. And the combination of where the content comes from that is being sent to the website, we call a strategy here. Typical strategies that I mentioned here are implemented in the Workbox library I mentioned before, but you can also meet those names outside of the Workbox context, right? So let's look at them. What is actually their performance characteristic? In cache-only strategy, this is when you receive a request from the page, you check in the cache, and if it's there, you return, and if not, you fail the request. So this means you need to really have a high confidence that the resource will be in the cache, and if it's not there, you need a fallback. For example, an image for a banner, you serve always from cache, and if not, you have a background color in the CSS, right? So you need to have some. It might happen that it's not in the cache gets evicted every now and then, so you need to have a fallback. The advantage is that it's usually much faster than the network request. It's not guaranteed because it depends on the device characteristics and if the cache is not being busy with some other stuff on a given moment, but generally it's faster than network. Now, cache first is similar in a way that you first check in the cache. If it's there, you serve from cache, and that's this optimistic scenario denoted as opt on the graph. And only if it's not there, you need to go to network, which is the pessimistic scenario, because then you need to first wait for cache and then do the network request. Now, network only is kind of interesting. We usually implement it when you really need your content to be fresh. So you never go to cache, you always go to network, or we implement it when you want to have something called like transparent service worker. If you use service worker for other purposes, for example, serving the notifications, right, and serving the push messages, then you don't really want to provide any offline capabilities and caching capabilities. So I just wanted to highlight something that is called service worker boot up cost. Service worker doesn't run for free. When it's not being used for some time, it goes to sleep. For example, the user is not, checking your site on some of the tabs, which means when the user comes back, it first needs to wake up. This is this boot up time, and only then it goes to the network, which means you think you're not adding, any performance bottleneck to your site because, well, it's just going through service worker to the network, but actually there is a small chance that there will be some overhead. So this is actually less performant than having no service worker at all. So you need to be careful about that. Next strategy is the network first, which means first we go to the network, which means we really want to have we don't care so much about performance, we care about whether the content is fresh. So we serve it from network first, and only if it's not there as our second choice, we serve it from cache as a kind of fallback, as a backup. Usually this is useful for providing offline capabilities to your app. And now the most common strategy, I think. It's stale while revalidate. This is very good for performance strategy because when the user or the website requests a resource, you serve it immediately from cache, whatever is there, and at the same time you go and check for the updates. And when the update arrives, you can notify the page saying like, hi, I sent you this, but actually I have a newer version. How about you reload or replace the content? This is performant because both checks happen in parallel, so overall waiting time is shorter. And now, last but not least, it's not so much a strategy as a kind of a technique. You can use streaming, and with the Workbox library, streaming is very, very simple. If your content is constructed in a way that it kind of can be rendered linearly, let's say you have a header, and then you have some main content, and then you have a footer, you can combine different strategies and actually stream them to the page rather than wait for the whole response to arrive from somewhere. For example, you can get the header, which rarely changes, from the cache, and then the main article, which usually is frequently updated, from the network, and mind that this request doesn't need to wait, like the header doesn't need to wait for the main to be sent to the page because it's streaming, right? So the header first goes, the page renders the header, then the network comes from the network a bit later, the page renders that, and then the footer is being served again from the cache as a last bit. So if you look at the comparison of all those networks in a one graph as compared to the no service worker scenarios, you can see that depending on the different, scenario, which priorities you set, like whether your priority is performance or whether your priority is to serve fresh content, this can take shorter on average or longer than no service worker scenario. So you need to adapt that to different situations on your web page. Of course, you can also have a lot of other handlers. This is not this is just the most common scenarios that we see out there functioning, but you can also have a very custom one. For example, here I have a custom handler where I define first a strategy called cache first from Workbox. So I want to serve an image first from the cache, but if it fails, I can catch it and I serve a fallback instead, right? So all those strategies can be mixed and matched according to your site. So you can really experiment with this and find a solution that is best for your users. So now let's go back for a moment to this division we made on the Women Tech Makers site, right? We had 4 types of images and we wanted to have 4 behaviors. How would those translate to actual caching strategies? Well, the first one, as I told you, I decided to just inline the icons so there is no caching involved. I just put it in my HTML and don't worry about them anymore. Now, the branding and priority ones, because they're priority, they're super important, I pre-cache them in the install, and in Workbox you can do it just with this one-liner, and then serve from there. So there is really high chance they will always be there and that they will appear really fast on my user's device. Now the decorative ones here, I use routing strategy runtime strategy, which means I cache only images that the user visited, because there is high chance that they will come back to the same website to check again the agenda or the events. So I don't cache stuff that they didn't visit, which means I don't cache speculatively that something maybe they will need, because that would be just too heavy. So I cache only the stuff they visited, and I put these 2 constraints, which means I don't cache more than 50, and if they're older than X amount of seconds, milliseconds, then I just clear them from the cache, which helps me to manage, the quota, to stay below the quota. And now so they might not appear on the page, right? Because it's not guaranteed. I only cache the ones that were visited and only the 50 first ones. And then I start replacing them. So they might not be there, but it's still a usable site. And now the green ones, these are informative. So I use this fallback custom handler I showed you before. I just generate an SVG on the fly in the service worker in my JavaScript and return it to the page, right? So that's how it looks like when there is when the image was not found in the cache, then I just serve a custom SVG with the name of a given company. So, you just need to find the right balance. Generally, you need to balance the speed and performance of your site versus the freshness of your content and versus the reliability. And you really need to understand different resources to adapt your caching strategy accordingly. So just to sum up, here are the tips I have for you for designing your own service worker. First of all, don't just jump in, install service worker and cache everything. That will most probably backfire. You need to have a plan and proper design document, preferably written if possible, but at least have a proper plan in your head. Cut the fat, which means clean up your site and audit it that is performant before you start caching. Then be selective, don't cache everything, only cache the important bits of your site that are crucial for your users' experience on your site. Use content versioning. If you don't do that, you will end up at some point with incompatible versions of your assets. So be careful about that, and check out Workbox because it really helps with this versioning problem. There are a lot of automated tools provided there that can help with this, including Webpack plugin, CLI, and other tools. Control the size of your app. Size can be really a business advantage in the progressive web app world, so pay attention to that and control the size of your app, and then balance the speed versus freshness versus reliability in your caching strategies. If you want to learn more, we just launched recently the web.dev website, and there's a big section over there dedicated to reliability. It's called Network Independence, so you can go check out this resource. There's a lot of nice guides waiting for you there. And if you want to know a little bit more about caching strategies, and especially how to actually measure their performance impact, how to implement some monitoring of, for example, how often the cache is being used versus the network, whether this strategy for my real user base in Tanzania is actually faster than the one I use in Amsterdam, then you can go to this talk that me and my friend Philip gave recently on YouTube and learn some more about this. Thank you so much. You can follow me on Twitter. It's Devnuk. You can ask questions there or meet me directly after the talk, and that's the link for the slides if you want to go back to them later on. Thanks.